Artificial intelligence, AI, is a rapidly growing field, and one of its most promising areas is the use of neural networks. A neural network is a type of machine learning algorithm that is modeled after the structure of the human brain. It is designed to recognize patterns and make predictions by processing large amounts of data. A neural network is made up of several layers of interconnected nodes or neurons. Each neuron takes an input from other neurons and produces an output, which is passed on to other neurons in the next layer. This process continues until the output is produced, which is the prediction made by the neural network. The first layer of a neural network is called the input layer. It takes in the data to be processed and sends it to the next layer, which is called the hidden layer. The hidden layer performs calculations on the input data and passes the result to the next layer. This process continues until the output layer is reached, which produces the prediction. Neural networks use a process called training to learn from the input data. During the training process, the network is presented with a set of input data and a corresponding set of output data. The network then adjusts its internal parameters or weights to produce an output that is as close as possible to the expected output. The training process is repeated many times with different sets of input and output data, and the network adjusts its weights each time to improve its performance. This process is known as backpropagation, and it is what allows the neural network to learn from the data and make better predictions over time. One of the key advantages of neural networks is their ability to handle complex data. They can recognize patterns in images, sounds, and other types of data that are difficult or impossible for humans to discern. This makes them well suited for applications such as image recognition, speech recognition, and natural language processing. However, there are also some challenges associated with neural networks. One of the main challenges is the need for large amounts of training data. Neural networks require vast amounts of data to learn effectively, and the quality of the training data can have a significant impact on the performance of the network. This means that creating accurate and diverse training data sets is a critical part of the development process. Another challenge is the need for computational power. Neural networks require significant processing power to train and run, and this can make them expensive and time-consuming to develop and deploy. However, advances in hardware and software have made neural networks more accessible and easier to develop and deploy. In conclusion, neural networks are a powerful tool in the field of artificial intelligence. They can be used to recognize patterns and make predictions from complex datasets, and they have the potential to revolutionize many areas of our lives. However, they also require significant amounts of training data and computational power, and their development and deployment can be challenging. As AI continues to advance, understanding how neural networks work will become increasingly important for businesses, developers, and consumers alike.